Substance T is a hydrated salt, which means that there is the water of crystallization. Next, they say put the mineral wool loosely into the neck of the glass test tube. So when you see mineral wool, it's likely to prevent any form of splashing. Next, you read on and it says hit the test tube gently at first to drive off the water. So, because substance T has water of crystallization, here you may see some water vapor, or if the water vapor touches the cool test tube and condenses, you may see some water droplets. And then they ask you to heat more strongly. Every time you see heat strongly, you should think of decomposition. So, what is happening in this practical is that we want to heat gently to remove the water and then heat strongly to decompose substance T. Next, if you read on, it says not to breathe in the gas. So when it says not to breathe in the gas, you must think that the gas could be a poisonous gas. And what could be this poisonous gas? So one of the gases that are poisonous is nitrogen dioxide. And nitrogen dioxide has a color. So how do we know this? We refer back to your notes regarding decomposition. So let's write it down first. So if you look at your notes, page 15 on decomposition, you will see that there is a decomposition forming a metal oxide, oxygen, and nitrogen dioxide, and it says it's a brown gas. And those are the metals that could be in the substance that decomposes to form your brown nitrogen dioxide gas. So we will write down that brown gas may be seen. Again, until you do the practical, you will not know if there's really a brown gas. Next, it says test with glowing splint. Glowing splint means oxygen gas could be present, and if it is present, it would relight the glowing splint. So again, we look back at our notes, page 15, or where it says oxygen and nitrogen dioxide, right? So oxygen gas could be produced. And if you look at your notes, page 17, for a summary about what gases could be produced, it talks about the droplets, water droplets from water of crystallization. It talks also about oxygen and nitrogen dioxide being produced, and it could mean that metal nitrates are present. So substance T could be a metal nitrate. So I'm going to write that down so I have in mind that this substance T could be a metal nitrate if oxygen gas and nitrogen gas was produced. Finally, it says to allow the contents to cool. So when it says to cool, we again need to observe is if there is any color change. So in these observations, we have to observe for water droplets, any decomposition, any gas, and finally the glowing split, as well as color change. So that's why the observations have many lines for part 1. Okay, for part 2, it says to the residue from part 1, which could be a metal oxide, to add this substance, aqueous cobalt 2 nitrate. Nothing about this is found in the notes, so you just put a question mark. It says to heat gently to remove water and to heat strongly. So it could be some decomposition where there could be a color change. So in certain experiments that they ask you to do, you may not know what is happening. If that is so, you just observe. So in this part 2, they ask you to leave it to cool and just describe the appearance of the cooked residue. So here you have to observe and write down the appearance of the cooked residue. Is it solid? What color is it? For part B, we are back to salt tea, and they ask you to add water because salt tea is a solid form. So remember, when we have a solid salt and when we dissolve it in water, it must be dissolved in water. It is because we want to identify the ions. So for the next few parts, it is likely that we are doing tests for ions. So for B part 1, if you read, the first line says add aqueous sodium hydroxide. So this could be a cation test. There could be some precipitate that may be seen when you add your sodium hydroxide. Then you read on and it says add aluminium foil and warm. So this portion, when you read that there is sodium hydroxide, there is aluminium foil, and there is warming. What kind of test is this? Can you remember? It's a test for an anion. What anion? Test for nitrate ion. And if nitrate ion is present, you would then get ammonia gas. And if ammonia gas is produced, it will turn moist red litmus paper blue. So here when they say test with moist red litmus paper, you expect that it may turn blue if there is nitrate ion. So you observe and you conclude. If ammonia gas is produced, it turns moist red litmus paper blue, means nitrate ion is present. If not, it's absent. Okay, we move on to part 2. Add sodium hydroxide, a few drops, and then until no further changes. So here, this is definitely a cation test. Because what we want to see is we want to see first the color of the precipitate, and next whether this precipitate is soluble or insoluble in excess. So your observation, you have to write down the color of the precipitate and whether it's soluble or insoluble in excess. Okay, and next, if they ask you for the name of the precipitate, remember that it's the cation and the word hydroxide behind. If they ask you to name the precipitate. The next part, again few drops. Here is aqueous ammonia, and until no further changes are seen. Aqueous ammonia is the second type of cation test. So you are looking out for the same thing, color of precipitate, soluble or insoluble in excess. So for part 2 and 3, after you observe, you make your conclusion on what ion is present. So finally for part C, you ask yourself what is the cation that is definitely present, what is the anion that is definitely present. Then you put them together and you get the name of the salt. Because a salt will always have a cation and an anion. So we want the name, so spell it out, not the chemical formula. For part D, they ask you to explain how you would prepare a crystalline sample of salt tea. Preparation is part of theory. You have learned this before under preparation of salts. There are three methods. If the salt is insoluble, the method is precipitation. In this practical, our salt is likely to be a nitrate. So if it's a nitrate, it will not be insoluble because all nitrates are soluble. So if this salt is a soluble salt that does not start with SPA, sodium, potassium, ammonium, the method we should then use will be reaction of acid with an insoluble substance, either our metal carbonate, or our base. So for this portion, you do need to refer to your salts notes or your reference book under preparation of salts. So just for the sake of this practical, let's assume that our salt could be a nitrate because of the anion test above, and pretend that the cation could be zinc. So let's say if it is zinc nitrate, our acid will be and our metal will be. So you need to think of what acid will give you a nitrate and what metal will give you that zinc. So to explain this whole portion is about 4 or 5 steps. Please refer to your reference book. For 2016, the reference book is in orange in color. And then you need to explain the steps. Okay, for the last part under main points, for 2016, please cancel out number 3 because